Today we will discuss the main core demands. Core demands. So first of all, daemon is a background process. Daemon is a background process. Background process. So we have 5 daemons, right? Yep. What are the daemons presented? Name node. Yep. Secondary name node. Secondary name node. Data node. So until 1.x, Hadoop 1.x, we have job tracker. So job tracker and task tracker. Task tracker. Next from Hadoop 2.x onwards, in the place of job tracker we have resource manager. Resource manager, and in the place of task tracker we have node manager. Node manager. Okay, these are 5 different daemons. These are 5 different daemons. So coming to name node, coming to name node, so first name node is a master daemon, right? Name node is a master daemon. It receives what? Storage request. It receives storage request. It receives a storage request and it prepares what? Metadata. It prepares metadata. So name node prepares metadata. Name node receives request and prepares metadata and monitors its slave nodes, right? So it monitors its slave nodes. So first one, it is a master daemon. It is a master daemon. Master daemon in HDFS. HDFS. It receives storage request and prepares prepares metadata, and next one, it monitors slave missions. It monitors slave missions, right? So these are the responsibilities of name node. Coming to secondary name node. Coming to secondary name node. Secondary name node is not backup of primary node. Secondary node is not backup of primary node. Not like existed architecture. Secondary name node is not backup of not backup of name node. So first one, secondary name node is not backup of name node. Okay. And next one, what is the responsibility of secondary name node? In Hadoop architecture, there is one more file called edit logs. There is one more file called edit logs. Edit logs. So first, fs image. Fs image is a file. Fs image is a file. It contains metadata. Metadata. This file is called fs image. This file is called fs image. Fs image. Fs means file system image. So fs image contain metadata. What about edit logs? Edit logs. After placing file, into Hadoop cluster, means data is stored into different data is split into multiple blocks and stores into our Hadoop cluster, right? Data split into multiple blocks and stores into our Hadoop cluster. So assume data is presented in this manner. So here we have metadata. So mapping information is presented in fs image. Fs image. Okay. So complete mapping information is presented in fs image. After storing, if you change anything on existed data, if you modify any operations on HDFS file system, HDFS file system, HDFS file system, the entries are the entries are stores in edit log file. Edit log file. So this is called, so modified entries presented in where? Edit log file. Example, changing permissions, changing file permissions, changing file permissions, comma, changing ownership, changing ownership, etc. So on existed file, if you change any permissions or any ownership or any other permissions, the entries are stored in edit log file. Entries are stored in edit log file. Entries are stored in edit log file. It will not changes that directly into fs image. It will write modifications in edit log file. Okay. So here secondary name node every 1 hour, every 1 hour, every 1 hour it merges, it merges. Yep, that's what I'm saying, Jayan. So what this name node do? So this is secondary name node, and this is secondary name node, and this one is name node. Okay. What this secondary name node do is, secondary name node takes these two files, takes these two files into its memory, takes these two files into its memory and merges these two files and prepares new file, new FS image. It will merges these two files into new FS image, new FS image, new FS image, and updates this new FS image into name node memory and removes this edit log entries. So new FS image contain all changes. New FS image contain all changes. Okay? Yep.
Recover data into this nodes when it fails
Yep.
this mission, it will go to that another data and node and
Yep.
at that time it will change this automatically.
No. This secondary name node purpose is only merging these two files into new FS image and update this new data into FS image. It does only this operation. So here what name node is doing, name node preparing two files. When you create any file, it will create FS image metadata. When you update that file, like modifying file permissions, changing ownership, like that, if you perform any operations, it will entering that information into edit log. So secondary name node every 1 hour takes these two files into its memory and performs merging operation and stores this new FS into name node memory and removes edit log entries. Okay, so this process is called check pointing. This complete process is called check pointing. Check pointing. So this complete merging process is called check pointing. Yep, Sunil, FS image is for name node only. So for storage, for retrieval, name node uses FS image. So finally, name node requires FS image, not any other nodes. It merges FS image and edit logs. Edit logs is called check pointing. Check pointing. The time is configurable. Time is configurable. Instead of 1 hour, if you want to change 10 minutes, we can configure. Okay. Secondary name node requires same configuration of name node. Secondary name node requires same configuration of name node because it using FS image edit logs into its memory. So whatever the memory we allocate for name node, it is recommended to allocate same memory. Yep, it removes old file and places new FS image. Okay.
From FS image and from editor first is stored in the name. Then it merged by the secondary name node and create new FS image.
Yes.
Then we indicate with the change in the FS image.
FS image. Okay. Next one, data node. data node. Data node is a slave daemon. Data node is a slave daemon in HDFS. So what is the responsibility of data node? It receives, or it stores the data. It stores the data. It stores the data and it sends heartbeat signal. Heartbeat signal to its master. Its master. So responsibility of name node is it stores the data. It stores the data and it sends a heartbeat signal to its master node. Okay. We can take multiple, or we can run. We can take, or we can run. We can run data node on multiple machines. No, during the checkpointing, it will not wait for. It is not in maintenance mode. Even you can write the data into Hadoop cluster. So it will take FS image and metadata into this one. Then it is updating this data into here. So let's see job tracker or resource manager. Job tracker or resource manager. First, it is a it is a master daemon. It is a master daemon in MapReduce architecture. In MapReduce architecture, so job tracker is master in MR1 architecture. MR1 architecture. Resource manager. Resource manager is master in MR2 architecture. So this is also called yarn architecture. MR2 architecture is also called yarn architecture. We will see what is yarn architecture later. So checkpointing happen in every 1 hour. Checkpointing happen in every 1 hour. It is configurable. It is configurable. First, we take job tracker or resource manager in separate machines. We take job tracker or resource manager in separate machine. It is recommended to take job tracker or resource manager in separate machine. So first point, it is recommended to take job tracker or resource manager on separate machine. So it is recommended to take job tracker or resource manager on separate machine. Job tracker or resource manager receives processing request. Job tracker or resource manager receives processing request. processing request. Yep, it's separate mission. Yesterday I said that we take mission, not server hardware. It's a mission, not server. Yep, we'll see here. So processing request is received by job tracker and resource manager. Then this mission communicates with the name node and gets the information of file blocks. Example, we want to read file 1. File 1. So resource manager or job tracker communicates with the name node and gets the metadata information, and based on that metadata information, then it will assign it will assign tasks to tasks to task tracker or node manager. Task tracker or node manager. Simply we can say assign task to its slaves. Assign task to its slaves. If it is a job tracker, it will assign task to task tracker. If it is a resource manager, it will assign task to node manager. Okay, data node or and task tracker or node manager. Okay, so next important point, it will monitor it will monitor its slave missions. Its slave missions. It monitors its slave missions. So it will assign task to its slave missions, and it monitors each slave mission. Okay. Next one, task tracker or node manager. Task tracker or node manager. I'll explain this application master in Yarn concept, Jaydev. We already discussed secondary name node. We didn't miss. Okay. Coming to job tracker or sorry. Coming to task tracker or node manager. So it is a slave mission. It is a slave daemon. It is a slave daemon. So responsibility of this slave daemon is it process or it executes jobs. It executes jobs or tasks assigned by assigned by its master. Assigned by its master. First responsibility, it will execute jobs or tasks assigned by its master, and it will update update status of status of task to its master. So this is called heartbeat signal. Heartbeat signal. So it will update status of task to its master. Okay, so here we have two types of communications. One is master slave communication, and master master communication. So master slave communication means data node to name node, task tracker to job tracker, and master master communication means job tracker to name node or resource manager to name node. Okay, two types of communications. Yep, in yesterday we discussed status means, so here assume task tracker processing this block, so it will update uh, status saying it is completed 50% or 70% or 100%. Okay, so it will update status of task to its master. If block file means it's responsibility of data node to name node. Name node. It won't require, right? Yep. See, slave to slave communication is not required, because assume file 1 is presented in data node 1 and data node 3 and data node 5. Assume block 1, block 2, block 3. So name node sends this block information to job tracker, and job tracker started or assigned task to task tracker 1 and task tracker 3, task tracker 5. Okay, so here task tracker not required to communicate with the data node, because it already has a task to process this block. Okay, so some important notes in Daemons concept. It is highly recommended. It is highly recommended, highly recommended to take good hardware to name node. Simply we can say reliable hardware. Reliable hardware. Reliable hardware. Because if we lose metadata, or if we lose name node, we cannot access data, right? Even though data is available in Hadoop cluster, we cannot access this data. We don't know what is this block, what is these blocks. This mapping information completely presented in metadata. So if we lose this name node, we lose everything. So we cannot access this data from cluster. So that's why it is recommended to take reliable hardware to name node. Second one, it is recommended to start all all master demands on separate missions. It is recommended to take or run master demands on separate mission. Yep, resource manager responsibility here. One of our friend, resource manager cannot. can talk data node. So there is no need to talk resource manager with data node, right? So resource manager responsibility to assign task. So it will assign task to node manager, not to data node. Data node responsibility to it communicates with its master name node. Node manager responsibility to communicate with its master. Okay. So it is recommended to run these master daemons on separate machines. Next one, it is recommended, highly recommended to run data node and task tracker or node manager on same machine. Same machine. And one more important one, admins periodically takes backup of FS image. So FS image is very important. So if we lose FS image, we cannot access this data, right? We cannot access Hadoop cluster data. FS image is very important. So admins takes backup of this image, FS image. Okay. So this is one more important note. One more important note. In latest versions, secondary name node is also called check pointing node. Check pointing node. So we cannot see secondary name node in latest versions. If you see check pointing node, we can simply say this is secondary name node. Okay. And one more important point, all these daemons are Java classes. Java classes. So how do we say it is a class? So there are some naming conventions in Java. Every Java class name, first letter is capital. If class contain multiple words, if class name contain multiple words, each inner word, first letter is capital. So if you observe name node, first letter N is capital, name, and second inner word, first letter is capital. Coming to secondary name node, see S is capital, N is capital, and N is capital. It follows some naming standards. One more important point. So in high availability, high availability. In high availability, we take multiple name nodes, right? Assume we taken two name nodes. So name node 1 and name node 2. Name node 2. So if name node 1, one name node we can make it as primary, and another name node we can make it as secondary instead of uh, secondary passive node, and this one is active node. Active node. So if active node goes down, in active node goes down, passive node become active, right? So how it reads FS image or metadata of name node 1. So for that one, here this FS image is a file, right? FS image is a file. So we create FS image in NFS. NFS. So NFS means network file system. Network file system. So we create NFS file system and we share this file system. So both these name node 1 uses this one and name node 2 uses this one. Name node 1 and name node 2 uses NFS file system. Sorry. NFS file system. Okay. So this is common file system. We can set this file system to any number of machines. NFS file system is a common file system. We can share that file system to any number of file systems. So FS image we create in NFS file system. So browse this NFS and NAS Uday. So it's completely related to network. Simple example for NFS is, so I have a NFS file system. So we created NFS file system. Location, assume that location I created slash OPT slash sales or transactions. Assume I created one NFS file system location. NFS file system location. Then I configured this NFS file system to different ATMs. Different ATMs located in different locations. So NFS system mainly used in ATMs. So whenever you do any operations on ATM, assume ATM 1 and ATM 2, ATM 3, ATM 3. So assume if you do any operation, means it may be withdraw, it may be balance inquiry, it may be transfer, any operation. So ATM writes data into slash OPT slash trans, assume transaction. So we configured this NFS file system into this ATM memory. So this ATM thinking that it is writing data into this transaction file. ATM thinking that it is writing into this transaction file in its local file system. But actual data is going to write where? In this network file system. Okay. So we configure like a local file system on our machines. So if you write any data here, it will store data into network file system. Okay. So this is uh, called NFS, Network File System. This NFS concept was introduced by Sun Microsystem, Sun Microsystems. Because of this, we can achieve common file system for multiple systems. It automatically reflects. Pardon? Processing same. So if you observe our one, so this name node feeling that it is writing fs image in its local file system, but data is stored in where NFS file system. So once it is down, name node 2 thinking that it is writing in its local file system, but data is writing in NFS file system. So this is common file system.